welcome back to AI Path. Core Agent Systems, Part 4. So far we've built one agent that can think, remember, and reason. Today we ask the next big question: what if one agent isn't enough? What if you need a whole team? We'll cover the 4 big multi-agent patterns and, just as important, when multi-agent is actually worth the extra cost. Let's get into it. First, the honest question: why even bother with multi-agent? Single agents are simpler, cheaper, and easier to debug. So when do you actually need a team? 3 reasons. 1. Different roles. Some tasks need a planner, a coder, and a reviewer. Trying to make one agent be all 3 in the same prompt usually goes badly. 2. Different tools or permissions. Maybe one agent should only read the database, another should only send emails, and a third should never touch production. 3. Parallelism. Some work just splits naturally into pieces that can run at the same time. If none of these apply, stay single agent. Multi-agent is powerful, but also slower, more expensive, and much harder to debug. Okay, you decided you actually need multi-agent. There are 4 big patterns. Pattern 1, Supervisor. One boss agent decides what to do, and delegates each step to a specialist. The specialists report back, the boss decides the next move. Like a project manager with a team. Pattern 2, Sequential Pipeline. Agent A finishes, hands off to Agent B, who hands off to Agent C. Like an assembly line. Each agent has a clear job and the output of one is the input of the next. Pattern 3, Debate. 2 or more agents argue about the answer. One proposes, another critiques, and a judge picks the winner. This catches mistakes and reduces hallucinations. Pattern 4, Swarm. Many small agents work in parallel on pieces of a problem, and there's no central boss. They share state, find their own work, and merge results. Most production systems use Supervisor or Sequential. Debate and Swarm are amazing when you really need them, but start simple. So how do agents actually talk to each other? 3 things to get right. First, shared state. Every agent needs access to the same picture of the world. Usually that's a single shared object that all the agents read and write. If 2 agents have different versions of reality, your system breaks. Second, handoff messages. When Agent A is done and passes work to Agent B, B needs more than just the answer. It needs to know what was tried, what failed, and what's left to do. Pass the context, not just the result. Third, who decides who's next? In Supervisor mode, the boss decides. In Sequential, it's hard-coded. In Swarm, agents vote or grab work themselves. Get these 3 right and your team works. Get them wrong and you'll spend a week debugging why Agent C is doing Agent A's job. Now the warning section. Multi-agent fails in a few classic ways. Number 1, agents keep handing work back and forth and never finish. 2 agents bouncing the same task is one of the most common failure modes. Fix: set a max handoff limit. If you hit it, stop and ask a human. Number 2, cost explosion. 5 agents talking to each other can easily use 10 times the tokens of a single agent. Watch your bills. Number 3, lost context. Each handoff is a chance to drop something important. Always pass the full context, not just summaries. Number 4, which agent broke it? When something goes wrong in a 5-agent system, tracing the bug is much harder than in a single agent. You need good observability before you scale up. Knowing these failure modes upfront saves you weeks of pain. Quick recap. Go multi-agent only when you have different roles, different permissions, or real parallel work. For patterns, Supervisor, Sequential, Debate, Swarm. Get shared state, handoff context, and routing right. And know the 4 classic failure modes before you scale up. Next time is the big one, putting it all together. We build a small real agent that uses every concept from the whole series. Memory, reasoning, planning, guardrails, and even a little multi-agent. If this helped, hit subscribe and I'll see you in part 5, the finale.